This is the fourth in the series of videos on nomenclature. We're continuing with binary ionic compounds, which means the two components are an anion and a cation. In this video, we're going to go from formula to name to formula, and we've done this for monoatomic ions, but this time we're going to add polyatomic ions. So for a real quick review, ions have a charge, monoatomic ions have only one atom, polyatomic ions have more than one atom in them. In the polyatomic ions, those atoms are superglued together. They will not break apart. And the overall charge of any ionic compound must be 0. Total positive charge must equal the total negative charge. Examples of polyatomic ions are SO4 2- or sulfate, NO2 1- or nitrite, NH4 1+, which is ammonium. There is a list in your packet of a number of polyatomic ions, and you'll also receive other ones. I don't expect you to memorize them, but hopefully through frequent usage you'll begin to learn some. And the overall rules for naming are going to stay the same. Now you just have to add the polyatomic and recognize that it is. But there is one new rule. If you need more than one of the polyatomic ions to cancel the other charge, you're going to add parentheses and subscript around the polyatomic ion. You do not distribute the subscript. And I will show you an example of this in a little bit. Going from name to formula is what we've been doing with the monoatomics. And so we're actually going to do this with an example. We've got sodium chlorate. We know that sodium is Na. It's a representative element in the first column, so it has an ionic charge of 1+. We look at the chlorate, and because it ends in ATE, we know it is a polyatomic ion, because monoatomic ions all end in IDE. So we look on the sheet, and you see ClO3 1-. The 1+ charge on the sodium cancels the 1- charge on the chlorate, and so sodium chlorate is this structure. How about copper 2 hydrogen carbonate? Well, copper 2, because of the Roman numeral, and this being a transition metal, we know is Cu2+. Hydrogen carbonate is definitely not a monoatomic ion, the most obvious reason being it ends in ATE. Also, you can see the word hydrogen and the prefix carbo. So when it is looked up on the sheet, you see HCO3 1-. Now it'll take 2 hydrogen carbonates to cancel out the total charge on the copper 2 ion. So copper 2 hydrogen carbonate is written this way, parentheses around the polyatomic ion, followed by the subscript. You may not distribute the two because these two chemicals are not the same thing. Going from formula to name, we're going to follow the same steps. With representative elements, it's pretty simple. You name the cation, you name the anion. You do not use prefixes, unless, of course, the prefix is part of the ion name, and then you're done. So, for example, if you were given this compound and asked to name it, since you only know how to name binary compounds, you need to find the two components. The parentheses are a good giveaway. The Ca is a metal, so it is the cation. The NO3 must be the anion, and it's obviously polyatomic. So Ca is calcium. You look up the NO3 and you see that it's nitrate. This would be calcium nitrate. Here is another compound. Since it is a binary ionic compound, it must have two parts. The parentheses once again helps give things away. We're dealing with two polyatomic ions here. The NH4 1+, which is ammonium. The SO3 2-, which is sulfite. This is ammonium sulfite. But what if you're dealing with transition metals? Now we need to make sure we include the Roman numerals. We're going to follow the same rules that we did for the monoatomic transition metal ions. We're going to list the total number of cations and anions, calculate the total anionic charge, calculate the total cationic charge, which means just change the sign of number 2, divide the number you got in number 3 by the total number of cations that you figured out in step 1. Write the cation followed by the Roman numeral. The Roman numeral is equal to the ionic charge. Write the name of the anion. So let's start with this compound. It's binary. We know that it's got a transition metal in it because that's what we're working on. So the Cu must be the cation and everything else must be the anion. So the cation is Cu copper. There's one of them. We look up the anion. It's C2O4, which is oxalate. We see that it's 2-. we have one of those. The total anionic charge, therefore, is -2 times 1, which is -2. Change the sign to get the cationic charge. Now it's +2. Take that 2, divide it by the 1 cation. So it's got an ionic charge of +2. So now we know our cation is Cu2+, which we would write as copper 2. The anion is oxalate, so this chemical is copper 2 oxalate. One last example. We have this compound, binary, so we know we have a cation and an anion. The cation is the chromium, two of those, but we don't know the charge on it. The anion is S2O3. You look it up, you see that it's 2-. There are 3 of them there, so the total anionic charge will be -6. Well, if that total charge is -6 for the anions, then the cations is +6, just change the sign. Take that 6, divide it by the 2. You get +3. So the cation is Cr3+, which is chromium 3. The anion is S2O3 2-, which is thiosulfate. This chemical is chromium 3 thiosulfate. So to review, polyatomic ions have more than one atom, which is sort of a redundant statement since poly means many. The atoms in a polyatomic ion are superglued together. They don't break apart. You're going to follow the rules as outlined in earlier videos for this section. Do not use prefixes. Make sure the charges are balanced, and then we can move on to the last video of this section, which is to name binary covalent compounds.